Okay, let me start maybe without the hood. So welcome to my talk, Drop Database, a galactic story. So my name is Jaroslaw Ratajski. I am from Poland. So ja понимаю русский немножко. I speak English, sorry, my English is, I speak few languages, all of them bad. But I am developer, wizard, and an architect. That's what I call my role. I live in Lucerne in Switzerland because there is a quite beautiful mountain there, so among the dwarfs over the lake. I like the place. I work for a CSS insurance company. I like the company even though we don't insure your style sheets. It's a health insurance company. More or less my Pokemons, the technologies I loved some. Quite honestly, I love only this one. All of other I hate, but somehow it's not anymore in the mainstream. But okay, you can mail me or you can tweet to me if you wish, even now. Okay, so before I start the talk, I'll shortly introduce a concept of multiversum. Who has heard about it? Multiversum. Raise your hand. Who knows? Oh, great. You know the concept. So it's not from IT, by the way. So you know what this is? It's not WebSphere. What? What? Almost. Okay. In fact, it's something that's called orbital. So it's a probability density cloud. So if you are looking at an atom and there are electrons somewhere, and if you are trying to spot where it is, you've probably heard a lot of this quantum physics stuff, but generally, you've probably learned that it's completely random from our point of view. If we want to try to spot an electron in a particular moment of time, we may see it, for instance, there, or there, or there. But it's quite unlikely, for instance, to spot it there. It's because the more black this cloud is, the more probable it is to find this particular electron there. But people, so that's what quantum physics says, but people don't like this idea of something being so random, because those small changes really affect the whole universe, because maybe, I don't know, yesterday one electron took other position in other possibility, and then, for instance, I don't know, I had an accident, I didn't make it here. So, you know, those small random changes really can change the history, and there is a concept that there is no randomness. Concept says simply, every time that a random thing happens, in fact, the whole universe is forked. I hope you know what the fork is from Linux. Cool. That's so multiversum concept is simply that every time some quantum effect happens, so some random things happen, in fact, everything is forked. And there are, in these moments, created a lot of parallel universes, and from every point of this parallel universe, it's like child process, you see different version of this story. It's really like a fork, with the exception that we have a few atoms in the universe, a lot of them, and a lot of electrons, so this is massive Eber fork of everything, that every time happens a lot of forks and a lot of universes are created forked with a different version of the story. So if you are looking at the past, you are just one child fork of some history, and in this moment maybe somebody like you is looking from different perspective, but in his universe something else happened. The problem is you cannot contact with this person because in a moment of fork, all the connections are lost. That's the concept of parallel universes. It's called multiversum. It's quite interesting, completely useless because you cannot contact those parallel universes, but it's interesting theory. Okay, let's go back to the real life case, which I will use this concept. So in the real life, we have a galaxy. That's galaxy quite well known in Poland, but I don't have time to introduce you to this world. And there is a businessman in this galaxy, also quite well known. His name is Domino. And he has a dream about making Galact Pizza, so galactic-wide pizza delivery service. It's really a cool business, isn't it? So So he describes his domain, his problem. He wants to deliver pizza to about 10,000 planets. Because, okay, there are more planets in the galaxy, but on 10,000 planets there are creatures eating pizzas. We don't care about other creatures. And he wants to concentrate on 3 most important pizza types, so vegetarian, margherita, and Hawaii, and 3 sizes, yeah, like medium, large, extra large, yeah. So those only make sense for him. He wants to deliver those kinds of pizza. So every time an alien being, for instance, from this planet wants to eat pizza, he can just order a pizza. By the way, only one. Just has to choose variant, size, and order. Okay, that would be a service post customer. And because this Domino doesn't like to waste too much money, he has hired only one pizza boy that will be delivering both pizzas with one rocket. So, and he has a simple rule. The pizza boy should really first serve pizzas to those planets that really demand the most pizzas. So not first in, first out, as you know, but those really that requested the most pizzas. For instance, in this case, if you look at the system at the particular moment of time, if something like this exists for the galaxy, then maybe on one planet they want totally 4 pizzas, so the pizza boy should go there first. And once he serves this planet, then he may go to another one with 3 pizzas, and you see, and at the end, to those not very profitable planets. Because, you know, by the way, Pizza Boy is very fast. This rocket is extremely fast, really doesn't take much of time. Only thing that costs is the fuel, so because of that, he wants to go to the most profitable planets first. Okay, that's the domain. Okay. And then non-functional requirements. The Domino says, Pizza Boy is very fast, rocket is very fast, spaceship is very fast. So the only problem for the system would be a system. If we write an application, it should be able to process 10,000 pizzas per second. It's not orders 10,000 pizzas per second, but orders plus served pizzas. It should be fast enough to serve that many. By the way, who has systems that process more than 10,000 transactions per second? Okay, I don't even have that at the moment. But who has system that processes more than 1,000 transactions per second? Oh, okay. So there is someone who has that serves more than 20 transactions per second. Okay, quite honestly, if you do typical system in Java, above 20 transactions per second starts problem. 100 is already something interesting, and 1,000 is really, really crazy thing. So that is way above crazy. And then he also wants to check regularly, like 10,000 times per second, with his wife, how many standing orders are there in the queue, just to keep if his business runs well. Okay. So he hired the group of alien developers from different planets. They look like this. And right now I will tell you the story in 2 parallel universes. What happened? So, we have a normal universe and we have other universe. The name is for particular reason. By the way, there were once one universe, but it forked because of some small change in this quantum effect. So in the normal universe, alien developers have listened to this story, to the domain, to the requirements, and they have decided to implement that in which language? What do you think? Java, of course, that was dominant technology for that kinds of services. And in other universe? No. They've chosen Java, surprise, ++. It means Java with something. You will see with what. Better Java. So, by the way, code for the normal universe is on a GitHub. I have stolen it from this galaxy, so I have just deployed it on a GitHub, so you can check anytime. So, on this normal universe, they started to implement in Java, and they started from domain. So, what would be the most important object for domain? Of pizza, that was the first thing they thought, but after a while they realized, in fact, the most important thing for them is order. So that's when they really started. Order, public class order. You see, that's really all the definition. Yeah, it's order with some kind of ID, strange, variant size. Yeah, so like this. By the way, you don't see getters and setters things. Who writes programs in Java like this right now? We have a few brave people, but exactly it's 2016. You don't have to write getters and setters anymore, really. And they really also implemented some enums. That was more or less their domain. What is somehow stored somewhere. Okay. And then they started to define the business interface. So for them it was like the most important interface is for customers. Place order to some planet, variant size. By the way, I've said one pizza at a time. So that's the order for a pizza. I hope it's easy to understand. And it returns for some particular reason some kind of strange ID. Okay, that's what is most important. Then for Pizza Boy and for the generally back office operations, they need two other operations. Take orders from best planets, so really get list of orders to the most profitable planet, and then this small operation counts standing orders, so how many orders are there in the waiting. It's really, and even they defined just total interface for everything, Galactic Pizza service. It's Galactic Pizza delivery and Galactic Pizza orders, whatever. They had this idea. So, and they started to implement the system in Java. So they've started with place order. How can you implement a place order? So the most important problem would be how to store those orders for planets. How can you do that in Java, that you store for every planet how many pizzas are there? Cool, they started with map of list, like this, private final map string list. Oh, right there, you see. And hash map. And it was okay solution for the beginning, but they quickly realized there is one problem, because this list, as a value, has quite rich interface. So it's really good idea to wrap it in something that encapsulates the list and only provides you the most important operations. So they created a structure called planet orders that I will show you in a short time. That's basically wraps a list. And then, this is the structure. So you see planet orders is simply a list, and it has operations like assign order, which is simply a wrapper for add, and is empty, that checks if the list is empty. That's more or less this, what they really needed. And then placing order. You see, it's very simple. They also introduced some kind of sequence to just distinguish orders, and it's simply long ID, order sequence plus. Then they create order, and they call this funny operation assign order to planet, which is defined here. Oh, it's quite okay that I can touch it even. So it looks like this. We have an order. So from maps of order, and right now, raise your hands who has used compute if absent before. Oh, very well, because quite honestly, mostly when I ask, people are just surprised. What is this? And this is standard operation on a map. So if we look something for a map, from a map, we can typically see two things. Either the structure is there, so it's something, then it would be easy. If there are some orders already, then we simply assign new order to that. But can happen that it happens for the first time. There was no order before for this planet. Then we will get a null. But since Java 8, there is a possibility to say, in such case that there was nothing before, don't return null, create it with a given supplier right here, and return. So we simply spare with that an if and some really dirty immutable operations. We don't see them. That's a cool thing in Java 8. I am really proud that a lot of you know this thing. Cool. So then they added one simple thing, because they wanted also to count the standing orders, and for some particular reason, they've chosen not to do that with a long, but atomic long. I will explain this reason later, but I hope you know that atomic long is simply concurrent accessible long. Simply like that, and after the order is created, they simply increment it. And that's basically all that they needed to implement place order. So right now comes the trouble. We want to find the best planet for the pizza boy. We want to implement this take orders from best planet. How can we do that? So first implementation, if you look at this, would be maybe we should go all the values of a hash map and sort them and find the best one. And that was the first solution they used. But you know, sorting, if there are 10,000 planets, every time the pizza boy delivers, that would be a pretty time-consuming operation. So they decided to use this thing called priority queue. Who has used priority queue in Java? Cool. Also, point for you. It's really the first time on the audience, and I see more than 2 hands. Really good job. So priority queue is simply, a structure that makes this prioritization automatically behind, so you can automatically get the best planet. If you only provide some kind of comparable interface, and there is a problem with this implementation. If they did it at the beginning like that. So after assigning order to planet, offer puts. What would be wrong with this implementation? If you use priority queue, the sorting of the planets may never change. So if you put few objects to the priority queue, the sorting should never change. Those objects should be immutable according to the compare to operation. So, because they in fact changed it, they couldn't sort planet orders, they had to write something else that was a planet orders wrappers, and it's simply an immutable version, a memento of planet orders. At the moment of putting, it's simply like stored how many planets were there. And that's a small change. This planet order wrapper is very simple structure like this. It only preserves this size of the moment of storing it, nothing more. And it has this compare to. So that was the okay solution, good enough solution. And right now they started to implement this take orders. That's pure Java solution. So from the orders, okay, this is from planet orders to this structure for planet, they implemented take orders. It's simply like give back the original list and clear the existing one. So it's mutable operation. Okay, so how did they do that? I don't have that much time to explain everything, but it's quite here. We take the best object from these planet orders. Then it might happen because it's old Java API, it's null. So it means nothing is on the priority queue. In that case, we don't do anything. Otherwise, okay, we don't go, we skip this part. Otherwise, we found something, but it might be empty because for this planet, already someone delivered something. So then, if it's empty, we just look for the next one. And we just polling till we find something. And at the end, we return this optional. Because it's really always good to, if you have something that can be null from this, to wrap it in the optional in our API to be clean. And then, if we find something, we map it to the orders that are there. And we have simply the list of optional planet orders that then we can take a list from this very simply and return orders. It's just to make it clear, very simple operation. The one funny thing that there happen is, okay, I won't explain all the problems, but it's pure Java implementation that you can do in, I don't know, 20 minutes with tests and everything. How to get it. Okay, and by the way, they almost forgotten, but tests showed them that after they take orders, you should decrement this orders total to keep it to keep the counter of orders constantly the same. And that was the most complicated operation they had, with a pure hash map implementation with a little help of priority queue, and then counting standing orders, so how many the third, the last operation was simply like delivering this counter that already was incremented and decremented. So, and it was like hash map implementation of the service. Galactic pizza delivery on the hash map. What's wrong with that? What do you think? Concurrency. That's the only problem that's wrong? Okay, concurrency surely is on the list of the problems they've spotted. Okay, they also thought maybe the persistence is really not the best one in the world that they provided with this solution, yeah? Because what happens is the system is restarted. What? Yeah, so exactly there. They've spotted two problems, but then they had old guy that told them it's very easy. Both problems are very simple. And then right now I will explain you little magic. It's really marked with this thing. So they used something called persistence controller. That's a container for something persistent. So they started, in fact, to implement the Galac Pizza server service for the second time. Before they created with this hash map, this Galac Pizza core. It's a hash map implementation. And then they used this controller, and they simply built that. Controller is with builder something on the folder pizza, where you create a new thing with this constructor, and then you start it. And then this controller has few methods, and one of them is execute and query. What execute and query does? It simply takes a lambda and executes it. So in this lambda, we call the original operation. We simply call from the core. So it's simple delegation, nothing really interesting here happening. If you look at take orders from best planet, it's also simple delegation. And if you look at count standing order as a simple delegation. But there is a little magic, very simple. It's written in Java, it's open source. Execute and query does also one thing first. This lambda is stored on the disk in some kind of log. What is in fact stored is what kind of parameters are there. This is lambda serialization, simply, with some library done. So you serialize that I want to call on the core function place order with these three parameters. And here it says I want to call take orders from best planet. In this case, I don't have any parameters. Here, because it's query operation, nothing is stored on the disk. And that is the first thing. So we store on the disk what was called with parameters. It's very simple to implement that in Java, this execute and query method. And it does also second thing. It simply makes a lock. So before starting this execute and query, it waits till all other operation execute and query are finished, then it starts. Because it's very fast operation on a hash map, it ends very quickly, and then another can start. So this execute and query are processed sequentially, one by one, never two at a time. But query operations happen concurrently, and even with execute and query. And because of that, if you remember, there was this simple atomic long, because that's the only place when two threads can meet at something. Querying threads with this mutating, because there is only one mutating thread that does something with our domain. And that was simply done. And right now I will skip quickly to the other universe, which I've stored that. And this universe might be more known to you. So Java++, those guys wanted to start with order. So because you know those are Java guys, every time they start to implement something, they think about the table in MySQL. So obviously they wanted to name the table order, but it appears to be reserved keyword in SQL. So they had to use T_order. Then they had put some magic in front of the class, so very, very important magic. And then they used even more magic, and at the end they had more or less the same class order with some final values. And this very strange thing here, because they used Hibernate. For some reason, Hibernate won't work correctly if you don't have default constructor. So the problem is, what is an order with default constructor? What it creates? Very strange order to null planet, to null whatever. That was the problem, so they decided to use nullster. But okay, that's the only dirty thing they had. So they started with Hibernate. Who knows Hibernate or similar thing in JPA? Okay, cool. So it would be easy for you. I won't describe this thing. So Java developers, okay. This part was simple. So they even connected to MySQL, and they've seen the table. Great, it works. So take orders from best planet. By the way, that was the first implementation. Group by count, it wasn't good. So they realized it wasn't good because it wasn't really fast. So they, for simplicity, they introduced the second table, so planet with a counter simply. So like second table, it's basically very similar to this solution in Java, that you have some second object that is a little bit like a cache, which keeps the number of orders per planet. And then they implemented that. And by the way, they didn't use JE or whatever because that was, at the time in this galaxy, they've forgotten about application servers because they knew they were wrong. And they, for instance, queried the database with this simple lambda, run in session, and then you put a function that takes session and returns you a value. It's very simple to create that function, you see it, but there are already, right now in Java, some frameworks that do it like this. So like in JOQ. Who has heard about JOQ? Okay, cool. So there are alternatives to JPA, which are way better, I think. But okay, we don't talk about this. So implementation was pretty much forward with querying the database every time and named queries to make it faster. So yeah, and Hibernate configs and everything. And after one day of coding, they had a system with MySQL and everything. So what happened in the real galaxy? Then right now, we will compare those solutions. Because there was this one demand that system should be really fast, 10,000 pizzas per second. So I don't have the, I can't show you real values from the galaxy, but in the code you see on the GitHub, you see some kind of simulation, what happened with, made at the beginning with JMH framework, but then later I put a simulation of this, so some kind of a micro benchmark. So 4 threads doing place order, 1 thread working as a pizza boy, take orders from best planet, and 2 threads doing count standing orders. All of the with some proofs that that the real work is done, that the real orders are delivered for real. Nothing is really too smartly optimized by JVM. Okay, and we'll see the results. So you can check later how good those simulations are done. So with some kind of warming up the JVM and everything, and with validation. So what has happened? Those 2 solutions. That was the Java one. They achieved at the first implementation, first simple, 40,000 pizzas per second. Is it okay? Yeah, it's very okay. So, and in this solution, 600 pizzas per second. Who is surprised by this result? What? Yeah. No, but you, who of you is surprised? You are not surprised. Of course, the operations on memory with simple block are way faster than translating something to SQL, than converting to Hibernate objects, etc. It's a lot of things to be done. By the way, 600 writes per second in MySQL, it happens mostly in simple system. It's really not that easy to achieve that, quite honestly. So, in this case, the boss was happy, another case wasn't happy, so it's a message to you. But okay. Then let's take a look at this reading operations. So in this case, because it was just looking at some atomic long, it's really, how the CPU, okay, CPU can do it even better, but I had to do some verifications to not get things too optimized. Then that's the result I got. And of course, with a MySQL, that's way better than writes operation. But comparing to this number, that's the difference, 6,000 per second. Still way below the expectations. So they were thinking what to do with that, especially in this world. So in this system, they realized that all those tests were done on this notebook, so they started to production on the notebook, because it was good enough. In the second case, they were looking for the, all this server room, cloud, whatever, and nothing really helped them. So in the first case, they had some time so they used Profiler, but we'll take a look at later on that. In the second case, what could they do? They started to profile MySQL. There are books about this, And you can read a lot. They even started to use profiler for Java to find the problems, and they found some things that could be done better. So, but generally, it was like a problem somewhere on the system in SQL. It's really not that easy. Here it was easy because it was Java, so they used Java profile and they found bugs. That this system was not enough performance. So, after some fixes, those guys had 60,000 pizzas per second and the others like 1,000. It was way better than they had before, but still not enough. In both cases, the owner wasn't happy. You know why here? Because if you have a system that's already works good enough, you don't touch it. So the owner was really bad at them, but okay. So in both cases, in fact, both galaxies, they've started it. Anyhow, on production, the owner had no choice. In this case, it was running okay, but in other also, but after a few days of operation, this thing happened. There was a problem with power. Like you know, just simply the power plant stopped working. And you know, and they even seen this thing. So in this world of MySQL, they were, oh, surely MySQL will store everything correctly. And in this other, okay, we have believed that it is stored on disk somewhere. Right now we will see how it works. And then they've seen this screen. Because it was on the laptop, so by default hibernation was enabled. So in fact, they haven't lost anything because they haven't even they didn't really need to take a look at disk because on laptop the memory was preserved. Okay, by the way, on server it also can work. So nothing really wrong has happened. But then came another problem. The Domino, the owner, said he doesn't trust Pizza Boy. Probably he delivers pizza to some other planets than he is expected to. He wants to know where exactly he delivered. So he wants to see the list of deliveries. So guys in both universes take a look at this problem, how to track this. So in this other universe that was, oh, simple. We'll not delete orders anymore because they were deleting them from database, only mark them as deleted. That's something everybody working with SQL learns. You don't delete rows, you mark them as deleted because you may need this information in the future. And those guys said, you know what? This system stores all these lambdas on the disk. After it's restarted, it executes them one by one in the same order. So what they had to do is simply to implement, in the implementation of take orders, right now add something like storing this thing to file, to CSV file, or store it to database, to table. Because, you know, this information was only needed for reporting. Where was pizza? They didn't need it in the system. It didn't really need to be fast. So if you don't need something, it's only for reporting. That's exactly the moment where you can use database. It's for unneeded data. So, and they, of course, both teams somehow, they did it. And then this happened. The guy said, I want this information for yesterday because something happened yesterday. And you know what? In this system, they already were deleting things from database. But in the system, the lambdas were on the disk, system was restarted, and everything from the start of the Galactic Pizza service was done once again. So I mean, the system has processed all this function once again, and this time simply filled the log in the database. So it was possible to see what has happened in the future. How great is that? So another real-world case, what has happened, of course, that he wants to extend his domain. Let's give people the possibility to compose pizzas, like something on one half, on the next half, on the third half, you know. So how can you model that? Those guys were doing that with SQL. They realized, oh, 20 tables should do the job, or maybe a text field, whatever. Yeah, that's really complicated. But here they thought, we use, this is all that this domain needs should be only done in object-oriented way. So every object in Java would work. So maybe they could provide a builder pattern, whatever. It's simply In this domain, they were not constrained, but how should the table look like? But I will skip this implementation. I want to show you the difference. What was really different? So as you've seen, the one was very fast, second was terribly slow. In one system, all the code was in Java. Even this execute and query, that is very simple Java project you can see on the GitHub. And on this other, code was in fact, if you look at this, was in fact in strings and annotations, all those queries. That's where the real guts are, not in Java. So this code is even, I like that is more or less strongly typed, but this version with annotation is generally stringly typed. So the most important things are in strings that at best your IntelliJ or Eclipse analyzes, but not the compiler. So this thing was very flexible. If you look at the domain, whatever you can model with Java, you can put here. Here you have to think what will fit into the tables. That's very limited. If you only work with databases, you don't see this problem. But this is really a huge problem. That your world, your mind, probably, if you worked with databases only, is shaped like a table. You just don't see things that are a little bit round. Okay. This thing you can check on the GitHub is had tests, because to test things in Java is very simple, even with persistence. By the way, the tests work in two runs. One with this simple hash map version, and the second with a real persistent to test if it really all works. And those are very, very simple tests. If you were ever, who knows TDD, test-driven development? Who does TDD? Yeah, because you go to the workshop, TDD workshop, and they show you assert 2 plus 2 may make 2 plus 2 makes 4. Great, looks cool. Then you go to your job, and then you have this assign order to employee. You have to start Oracle before test. It's all feasible, but it's really hard. So that's the biggest problem, in fact, testing. But there is also one thing interesting. Here, it was sophisticated Java. I had to show you the priority queue, compute if absent, a lot of things in Java. Guys in this domain never use this Java. They only have getters and setters. That's enough for them. It's cool. They don't have to learn Java at all. So we are, in fact, the first audience that really, I've seen a lot of people knowing those things that are, in fact, in Java for a long time. Okay, so why were those galaxies different? Because, funny thing, years ago, there was in fact, only one universe before fork. You know what was that? What is that? Memory. That's, in fact, core memory. By the way, here, there is a bit. So the last memory where you could really see with your eye a bit of information. It's really cool. And this memory was very expensive. Very expensive. Then there were, but it was a long time ago. Then in those universe, there was a moment called 90s. Cool moment. Computers had mostly one CPU, and memory was expensive, but something like 100 megabytes on server was possible. This made it possible, for instance, to work with Java, because Java with below, I don't know, 64 megabytes wasn't really working correctly. I remember those times. It was really hard. So disks, however, were slow and huge, but huge. Really, 2 gigabytes, well, that's big data, or 20 gigabytes. At that time, really, whole universe, whole one planet information you could store there. So it was really huge. That was a problem. How to work with 100 megabytes with so many informations? You have to somehow store it for a moment on the disk, but working on a disk is not really that convenient, so evolved thing that is right now known as SQL databases, and some technologies like JE, a little bit later, that were very convenient to work with the disk with a huge amount of data, but pretend you are doing a job in a memory with transactions and everything. Everything was fine. So it was slow, but fine. But then around galactic year 2003, something happened in the normal universe, because RAM became very cheap and huge. So 2 gigabytes was possible. So big data. Computers had multiple cores, so you are not really limited to one thread anymore on one unit. And alien developers started to use this power of Java, with Java. It was possible, and nothing was really there was no need anymore to store everything in database. What for? Because you can process everything in memory, it's good enough. Because RAM was cheap. And in other universe, RAM, around the galactic year 2003, RAM was cheap and huge. Computers had multiple cores, and nobody realized that. Just this quantum effect. And this is the moment of fork. Yeah? And this is what I call cargo cloud programming. You do as your fathers. Your fathers had a reason for that. This reason is long forgotten, but you still do this way because it works. It gives you fruits. Of course it works. Maybe it's not fast, maybe it's not funny, but it works. Okay, cool. So I believe that this other universe is a very good place because database vendors, they get money. So cool, one cool thing. Application servers vendors get money. That's second good thing. Power plants are very prosper. They can prosper because, they have to deliver power to all those servers. Hardware vendors are happy. Those guys that sell all those stuff are very happy. Business complains a little bit, but has no choice, has to pay. So we don't care about those guys. And developers have a lot more work to do, in fact. Because, for instance, to test something on database, you have to really put a lot of effort. So they are happy, they have work. Quite honestly, I see it mostly like that. Okay, they are happy, but they a little bit complain. Okay, so we don't go further with this, but let's take a look at a few other slides because I want to summarize it a little bit. So, I don't say that this solution, by the way, normal universe is perfect. It has some problems. So, I don't know if you know the problem with detached objects, so you have the same problems like with ORMs, with Hibernate, those. So, transaction isolations, in fact, you have the same problems. Testing, however, is here very trivial and here awful. So, by the way, I've told you this, I've shown you this scenario with performance. That is something that people really, oh, performance, cool, that sells well. But it's in fact for me not the most important reason to think about the normal universe. That's this testing that really makes a difference. Because in a real galaxy, this kind of wired performance is not that common. If you do some kind of a simple shop or portal for, I don't know, a few thousand people, you don't suffer really a performance problem. Cache. If you suffer with performance problem, typically with database, you have to config cache, and it's a horror. Here it's basically in RAM, everything in a hash map for a moment. That's all cache. So magic. In database approach, typically you just have magic everywhere with Hibernate. For instance, JPA, your code is polluted with magic everywhere. It will only work if you do everything correctly in strings. Here you have a little bit magic, I've shown you. I had to explain how this execute and query method works. And by the way, if you look what can you model, the domain here, as I said, is shaped to the tables. Here you can really use your imaginations. The only one limitation is you don't put thread in the domain. It's very silly, but okay. If you are in this other universe for some particular reason, there is a very easy way to jump to the normal one. So there are three ways. One is called, that's a very old project called Prevailer. I really loved it, I don't know, 10 years ago. Then I wrote this thing on a GitHub. It's very simple, really 1,000 lines of codes and everything is explained how it works. It's exactly for the storing of these lambdas. Well, okay, for any call in Java. Aeromem is my project, which I really wrapped only Prevailer to make API a little bit more modern and make it ready for Java 8. Nothing really more, but I consider this solution the best. Use nothing. Because it's so easy platform to write that you can do it on a weekend. And then you would know how it works, because it would be in your control. But okay, I know that people don't like to write programs in Java, so they will choose one of those solutions maybe, but okay. It's up to you. It's really one dependency. And maybe to explain a few things that happened, Previler builder is for this construction of this object. We have a builder that has a lot of options that where to store the log, the lambdas on the disk, how to create something if nothing yet on the disk exists. That's just optional thing that will happen only after the system is started for the first time and then built, and simply like that. And by the way, it looks very great if you use lambdas as on top, because the code is very concise, but you can't go with that to production. Because serializing lambda, it looks cool on presentation, it has a serious issues. So before going to, it's very great on rapid development, doing something on hackathon, showing for demo. If you really go to production with that, you have to replace all those lambdas with, real class implementation in Java. This lambda, they all inherit from command, and then you have to put this code here. It's very easy, but I don't just replace lambdas with this. But it's something you have to do before going to production if you want to really work with this system and change it for a long time. By the way, very important thing about concurrency, the system limits your concurrency so that all the changes, executes are done sequentially, one by one. It means that only one works at a time, so you don't have to worry too much about concurrency issues. You use hash map, you put things to that, because only one thread will be changing. With one exception, if you query, queries work concurrently to that. So all these places where querying and writing can meet, you have to do something. Maybe with synchronized, whatever. Best is to use special concurrent data structures that are in Java 8. Who knows some kind of concurrent data structures? Okay, what is your favorite, sir? Cool, yeah. Copy on write RLs. There are a lot of interesting structures that help to write that. But mostly people don't use that because typically people write getters and setters and they don't know these things exist. Okay, on the disk it looks like this. If you look at this journal, it doesn't mean that for every lambda that we've created we have one file. No, this file typically contains a lot of small calls inside. That's a log. And you see sometimes there is something called snapshot. It means for performance reason, if the system is working, I don't know, 2 years, and it's restarted, going all these 2 years of things that happened would be very crazy. Maybe you would wait a year to that. So this system has the possibility to do a snapshot, maybe from time to time, and simply store on the disk your state, and after it's restarted, it looks on the recent snapshot and only executes the events that happened after. Okay, that's technical thing. A lot of people think, okay, this is hash map, it should have fit to the memory, so don't worry about memory. Right now, it's possible to have a server with 5 terabytes, really. You can see the pictures. I don't say that Java, even with G1 heap, would work perfectly on that. I don't really know that. Because up to 100 gigabytes I could test, but below, I don't really know. But above, I just don't know, because I haven't tested. Surely there could be a JVM, standard JVM limitation, and of course, according to the system, when that big Java heap wouldn't behave well. I don't really know. But up to 100 gigabytes, it's still a lot of data, and it behaves, you can tune it to work correctly. Okay, so I will skip these things because, for instance, funny thing is, what if you migrate your data? Here you would have to, so in databases you migrate data using SQL. In this system you migrate data, really there is something in serialization with methods read resolvers. So you write migration scripts in Java. I know people hate Java, especially at that conferences, so they would rather write migration in SQL, which is more simple language, but here that's a drawback, you have to write migration in Java. Or you can use XML export. But if it comes to transactions, people ask me sometimes about transactions. What happens if, in the middle of this store to hash map, I want to also do something else, and then, I don't know, application is killed. What would happen? What do you think? So, sorry,
We have the last successful run this realized.
Yeah, so generally this system works very smart way. It's code that you can see this code. It stores lambda on the disk, then it executes it, and if something happens, an exception, then it simply says, oh, that was really a bad lambda, it caused an exception. What then it can do, it can simply remove it and ignore it next time. It means a system after restart wouldn't have this. And by the way, it means that after you get an exception inside of this execute method, you have a system in a bad version, because some partially it worked, partially not, so you have to restart. And this system also has something to make it faster, because typically you can configure it, it's by default, you have two versions of your system. One is safe copy, and one is for new lambda. So every new lambda is applied on it's called royal food tester pattern, somebody who tests food for the king. And if this tester doesn't die, the lambda is, okay, the function is applied correctly, then the safe version would also be done. So it means, in fact, even in this version, every operation was called twice. It's still so fast in memory that you don't see the problem. But if something happens, then it's cloned. So it means it's deep clone done, so this copy is just dropped, and you have some other. Of course, it means if you have like every second operation an exception, it would be very slow. But you typically don't design system to have exceptions so often. But okay, so in this system, you have to learn Java util concurrency. You have to really learn it, or you will have problems. That's the problem, because yeah, writing with Java. Replication is possible. I don't have time to dig in that, but it's very, in fact, easy. Indices. If you, for instance, want to, in fact, we've seen other solutions also. If you want to, I don't know, you have a really big hash map and you want to look at peoples that have, I don't know, particular name, there is a project that enables your indices in memory. It's called CQ Engine. And then you have very fast searches in memory with indices, so you can do things like or whatever. Yeah, it's sometimes better than simple, I don't know, text contains in string. And right now, to the most important thing, people are watching this presentation sometimes and they already realize that this concept is in fact quite known, because this is event sourcing. If we look at this lambda, every lambda is simple event. So system that you can recreate on using event, it's simply called event sourcing, this pattern. And this, what I've shown you, this library, it's, I would say, poor man CQRS plus event sourcing. It's some very simple Java solution, how to do that and understand it very quickly. Those solutions are not really new to Java. The CQRS, you can listen to a lot of videos. Right now, it's a hot topic on conferences still. And this system is very, I would say, poor man, very simplified version of such thing. But if you work for, I don't know, particular big company, and then they don't want to experiment with your too smart Java libraries. They want something enterprisey that costs something, I don't know, that at least support costs a lot. It happens. Then you can look at those solutions. Lagom, who knows Lagom? You know Lagom? Yeah. Exactly. It's a new platform for microservices from, you know, who has heard about Akka? So the company behind Akka right now started to do more for Java than for Scala, because Akka was possible to use Akka was possible in Java, but wasn't really nice. But they had created a platform called Lagom. In fact, this year it really started. Okay, it's already working, it's already productive. You can use that. And Lagom is simply, I would say, things from Akka gathered to one platform working well, and it's with Java first API. So it's very easy to use it from Java. Documentation is for Java. It has Maven built and things like that. So it's this. But behind, you see CQRS. So it's the same concept that you store events. Akka persistence is all from Lightband. Is this thing with Akka, and Akka persistence is one module to Akka that exactly works this way, event sourcing. And it's, if you love Scala, I love Scala, I hate Scala, okay, it's hard to decide, then it's possibly also interesting choice for you. And basically, there are a lot videos on YouTube or even papers you can find about CQRS because it's more complicated topic. I've presented you a very simple solution that is working according to CQRS rules. But by the way, because lagom akka persistence can store those even in different things. Like typical use solution right now, I would say the most common is Cassandra. There are others, but even on files. Even this Previler tool I've shown was a backend for akka persistence. But never store those events in SQL. It's really stupid because those events in those systems are also some blobs. You can't really read them. So storing this blob in table is simply stupid. Do it better in the file on other kind of database that works well with that kind of thing. So even better key, something like key store, whatever, yeah? Not really SQL, because just waste of resources. So that's something I've learned. Whenever I present, I have some demos, I put thread slipped often. Because if customer, real user, presses on save and it instantly answers, then it thinks, oh, it's a fake, it doesn't work. So really, that's a real problem. You don't get the feedback that something happened. So people also sometimes think it's just another in-memory database, but I think there is a difference, big difference. Because in fact, in this kind of approach, you think first about events. What kind of operations do you have? Then you should start model domain later, after you know what are your operations. And you store facts, what has happened versus you preserve your shared state. Because really, if you want to have a performance system, having shared state is a killer. Okay. The difference is you don't pollute your domain and your code with magic. And by the way, if you love things like clean code, clean architecture, here in this approach, it's very easy. Because if you have some kind of databases, whatever you do, your domain will be polluted with some crazy things because you jump from two different worlds, SQL and Java 1. And it's really, I have never seen a system where there were no such stupid things like, I don't know, default constructors or whatever if this system was using SQL. Always something very stupid because of frameworks or something like that. And here, you just keep your Java clean and easy. Okay. So the end, some of my advices. This is the huge topic. So you can have a lot. You will see how easy is that. But don't go to production on Monday with this. Because you have to learn a lot. If your mind is a little bit tably shaped, and you are somehow, it really stays there. So you have to learn first how this thing works. You have to become comfortable. So do something small. I recommend, I don't know, some open source projects, hackathons with that. Really something to first play. Then you will see how good is that if it fits for you, and you will get some experience. But my advice is generally, even if you don't go with the system, drop the database from, databases are good for some things, for storing not necessary data, that data that you don't need really. They are really good on that. And use them really as log for some such things, for reports, for data warehouse, but don't use them in the core of your system to really map every object on that, because it's really, 90s are gone. We have 21st century. You don't need that. By the way, this thing used Hibernate, this thing didn't use JPA and generally application servers, because if you listen, who is using application servers nowadays? Who are you? Okay, I'm still using even WebSphere. But generally, for new projects, I don't recommend that. Those times are gone. You don't need them anymore, really. So less magic, better code. Drop annotations, that's a thing. I consider the annotations in Java to be a new go-to. It's really like writing your code in annotations, polluting your code with annotations is simply, for me, it means you don't know how to program in Java. Especially, you haven't experienced a basic of functional programming. I mean basics, because most of the annotations, like, I don't know, persistent content, things like that, you can replace with very easy functional things, simply like that. You don't need them. And generally, you can drop magic. You can learn Java and algorithms if you think this language is cool. and you can feel the power altogether. And now, right now, I'm just after 1 hour. I don't know if you have time for questions. Do we make a round for questions?
Yeah, we can ask you.
Okay, so
questions.
if there are any
questions,
I'm free.
Okay.
Thank you for your talk. And how do you rate your IROM system, if I pronounce it correctly?
Okay, doesn't matter how you pronounce it.
Is it a prototype or production ready?
I would say it's a IROM system. This is something on a GitHub. I don't call it production ready because I have some simple system on that work for ages, but it's for me mostly a toy, and I recommend that this system, I can say, you can play with that, you can do some simple system with that, but I cannot provide you support for production. If you are a good Java developer, I am a good Java developer, I wouldn't have problems going to that to production, because I know I can handle every problem if I encounter any. But I don't sell anything. This is the open source solution. If you are ready to join and maybe solve some bug or whatever, if there happens, then go with that. I would say you shouldn't expect more problems than with the typical approaches. So JPA's implementations also have bugs. I don't know if the system has bug or not. So far I haven't seen. I have like 8 issues that most of them are solved, mostly with the configuration because it's not really customizable perfectly. And yeah, I'm typically solving those issues, yeah.
So do you know somebody besides you using it for some real projects?
So this thing,
yes.
So this thing, I only know guys that are using it, for instance, for funny open source projects. So in Switzerland, they have one of these. I am using that on few projects. One of them is living, I don't know how many years, few at least, and it even survived few restarts of a server. This is a funny game for CSS. It's a CSS Craft, but it's still working on that. And but I'm talking about AeroMem. That's a wrapper for Prevaler. Prevaler was used, and I'm not really sure at the moment, because I meet sometimes people that talking to me that this is very old thing, that they are using it for 10 years in a company. But it's like really, I've met few such people in my life, so it's surely not something very, very popular. So this Prevaler had a story behind. So you can think, but by the way, I wanted to sell you not this library, I wanted to sell you approach, and Lagom is new things, is becoming more and more popular. AK persistent is already quite well adopted in industry, so, and CQRS is already adopted. So it's about this. I don't say this library, but generally approach.
Thank you.
so we have no time for question. Find speaker, ask him questions, and thank you for presentation.